Today I'm going to teach you about the definite integral. A definite integral is the area between the curve and the x-axis. The definite integral of rate of change yields total change. You can see in the diagram the shaded region represents the definite integral. This is the integral of f from a to b. This curved symbol is called the integral sign and goes on the outside. Now, since this is a definite integral, it has limits, a being the lower limit and b being the upper limit. The function is the integrand, so in this case x is the integrand. Lastly, we have the variable of integration, which in this case is x, but if it were in terms of y, would be y, and so on. There are 4 ways to approximate a definite integral, and each way is a type of Riemann sum. The first way which is an LRAM, which is a left-hand rectangle approximation. The next way is an RRAM, which is a right-hand rectangle approximation. Then there's the MRAM, which is a midpoint rectangle approximation. And then lastly, there's trapezoids. Now there are 3 ways to evaluate a definite integral. The first way is with geometry of a graph, and as you can see in the example, you can find shapes in the graph, in this case a triangle, and find the area that way. The second way is with a calculator. You press math and then 9, and then that allows you to plug in the values into the definite integral equation. And then the third and final way is an antiderivative, and we will get into those now. Here's a list of the most common integrals and their antiderivatives. If you don't see one of these in the problem that you have, you use power rule, which is listed as number 1. Here's our example, and since it doesn't fit any of our common integrals, we're going to use power rule to find the antiderivative. For the sake of power rule, we are going to call our exponent value n. To do power rule, you need to do n plus 1 in the exponent spot, but then also n plus 1 in the denominator. That gives us 3x cubed over 3, which comes out to x cubed as our antiderivative. Now that we have our antiderivative, all we have to do is plug in our top and bottom limits. You plug in the top limit to x cubed and subtract the bottom limit plugged into x cubed. That gives us 8 plus 1, which is 9, which is our answer. Now you know all about definite integrals.